circuit analysis network theorem. In this video, so we are going to find out how to find out the unknown current in the given circuit. So you have to find out unknown current in the given circuit. There are many theorems are available here. We are going to discuss one of the theorem is Thevenin theorem. So Thevenin theorem states that the circuit with the two terminal can be replaced with an equivalent circuit consists of an voltage source in series with the resistance. See, this is our actual circuit, right? Our original circuit consists of a circuit with the DC source and a resistance. The two terminals A and B. This is replaced with the one voltage source in series with the resistance. So the Thevenin theorem says that when a circuit with a two terminal can be replaced with an equivalent circuit consisting of an voltage source in series with the resistance or impedance. So this is our original circuit that is replaced with the Thevenin equivalent circuit consists of an voltage source in series with the resistance. So the voltage source is called Thevenin voltage and the series resistance is called Thevenin resistance. Now we have to calculate Thevenin voltage and Thevenin resistance. So how to calculate a Thevenin resistance? So to calculate in order to calculate a Thevenin resistance, right? All the sources are replaced with a zero value source and the circuit is reduced to a single equivalent source. So in order to calculate the equivalent Thevenin resistance, we have to make all the voltage sources a zero value. The value of the sources make it as a zero and the circuit is reduced to a single equivalent resistance with respect to two open terminal. For an ideal voltage source, the internal resistance is zero, so it is replaced with a short circuit. If the circuit contains voltage source, that is replaced with a short circuit. For an ideal current source, the internal resistance is infinite, so it is replaced with an open circuit. If for calculating, if the circuit contains a voltage source, we have to replace it with a short circuit. If the circuit contains a current source, it is replaced with a open circuit. Now we can see one problem how to calculate the Thevenin theorem. Calculate the unknown current by using Thevenin theorem. So the problem is find the current through 10 ohm resistance using Thevenin theorem. So here if you see the diagram, circuit, this is loop 1 and this is loop 2 and this is 3. So we have 3 loops as 1, 2 and 3, right? 1, 2 and 3. So the given problem, find the current through 10 ohm resistance. So this is our 10 ohm resistance. So we have to calculate the current through 10 ohm resistance. So you have to calculate the current through 10 ohm resistance. So you have to calculate the current through 10 ohm resistance. So the given find the current through 10 ohm resistance. The first step 1. So we have to make that resistance as a load resistance. So the 10 ohm resistor we can to assign as an RL. So in the problem they given the 10 ohm resistance. We have to find the current through 10 ohm resistance. So step 1, you have to assign that resistance as a load resistance, and we have to find first step 1. So we have to find RTH. So RTH, step 1, you have to remove the load resistance. You have to remove the load resistance. Step 2, voltage source is taken as a short circuited, and voltage current, if they given a current source, we have to make it as an open circuit. So in this figure, we have they given two voltage source. So you have to voltage source should be converted into an taken as a short circuited circuit. So step 1, so remove the RL value, that is remove the RL resistor, and voltage source is a short circuited one. Right? This is the final diagram after removing the load resistance RL and convert the voltage source into a short circuited one, and the current sources, if it is available, it is an open circuited. So here we have a two voltage source that is a short circuited, and we remove the RL value. So between A and B we have to find out the equivalent resistance. Between A and B we have to find out the equivalent resistance. Okay, so I redraw the diagram. Right, so between from A we have a two resistance connected in parallel, and between A two resistors are connected in parallel, and these two are connected in series. Right, so from A 4 and 8 are connected in parallel, and from B 2 and 4 are connected in parallel, and these two are connected in series. So we can modify it and redraw the diagram. Right here 4 and 8 are connected in parallel, right, and 4 and 2 are connected in parallel. So for parallel means 4 into 8 by 4 plus 8, that is comes around 2.66, and here the two resistors are connected in parallel, 4 and 2. So 4 and 2 are connected in parallel, so 4 into 2 by 4 plus 2, 1.3. So by replacing these two parallel value as a 2.6 single value, and these two resistors are converted replaced with a single resistance value 1.3. Now between the A and B, so we have a two resistors that is connected in series. So by adding the two value, we can reduce as a single resistance, that is a RTH. So RTH value is 4. Next one we have to find out VTH. So for finding out the VTH, so we have to remove the load resistance. So we have to remove the load resistance. So I removed the load resistance, and we have three loops as loop 1, loop 2 and loop 3, or we can make it as a loop 1, loop 2 and center one is loop 3. Right, so between A and B, so we have to find out the Thevenin voltage. So first step 1, apply Kirchhoff's voltage law to loop 1. Okay, so Kirchhoff's voltage law is sum of the applied voltage equal to voltage drop across each resistance. So the voltage applied is 8, and the voltage drop across 4 is 4 into I, or current flow 4 into I, V equal to I into R. So I1 into 4 and plus I1 into 8. Right, from this equation we can find out I1 value. So I1 equal to 8 by 12, 0.667 amps. And next one we can taking a loop 2 and taking these as a loop 2. So loop 2, apply KVL. So sum of the applied voltage 4, that is equal to voltage drop across two resistance in the loop 2. So 2 and 4. So 2 I2 plus 4 I2. So 2 plus 4, 6 I2. So 4 by 6 equal to I2. So I2 value is 0.667 amps. So the next one is middle loop. Applying KVL to the middle loop to find VTH. Right. So we have a middle loop. We have a two resistance. One is 8 ohm and 4 ohm and a VTH. Right. So 8 into I1 minus VTH minus 4 I2. So you see the current direction, right? So 8 I1 minus VTH minus 4 I2 By substituting I1 and I2 in this equation, we can find out the VTH. So VTH and RTH are calculated. Next, we have to draw the equivalent circuit. So Thevenin equivalent circuit consists of voltage source in series with the Thevenin resistance. Right. So VTH value we calculated 2.6. VTH is 2.6 and R value RTH is 4 we calculated, and draw the load resistor between E and B. So now we have to find out the current flowing through 10 ohm resistance. So I equal to V by R. So V by R, V is VTH, V Thevenin, R is the two resistors are connected in series. So RTH plus RL, right? So RTH value is 4, RL value is 10. So by calculating these two values, we can get IL is 0.19 amps. So this is the method for calculating the current using Thevenin theorem. So Thevenin theorem, you have to calculate RTH and VTH. You have to convert these circuit into an Thevenin equivalent circuit, and we have to convert, and from that Thevenin equivalent we can find out the current flowing through the given resistance value.